Hello, I thought I'd just do a different video for a change and call this mystery tour, Rust mystery tour. What I'm going to be looking at is something that's new to me, really. I've not really read or done a huge amount of background reading about OpSec, malware, and Rust, and yeah, it just piques my interest more from the point of view of what I can learn by looking at some code examples. I've no intention of doing anything malevolent, and I've no intention of really getting too deep into this, partly because I've got a slight cognitive bias against Microsoft Windows, and it's always occurred to me that to become good at offensive or defensive OPSEC, um, IT network security, software security, whatever, you need to actually have quite a good understanding of Microsoft products, which I don't have and I don't want. So yeah, with that being said, let's just look at the start. So Rust malware, hacking with Rust is at Reddit. I just find Reddit a bit, well, for a start, the the bright white and just the fonts, it's just, I don't know, I find it hard to read. So the second link was this, Rust malware sample gallery. And the intention of this page is to collect and highlight malware written in the Rust programming language so that malware reverse engineers have a collection of Rust samples to practice reversing on. Malware written in Rust is rapidly becoming a significant problem, especially with the advent of high-impact ransomware families such as Black Cat. However, the knowledge in the malware reverse engineering, I guess because Rust is new, it possibly provides, or when I say new, it's obviously new compared to C. I guess it provides new attack vectors, and possibly it's easier to learn than C++. So I don't know. Let's I don't know if anyone's got any thoughts on that, but let's see what we can actually find. I think there's some links further down. Sorry for jumping about, but okay, this is from 2022. Some of these links are from a while back, but what I saw earlier when I was doing a little bit of research was some actual source code, so I want to find that. Uh, samples, write-ups, samples. So if we go to the, here we go. No. Write-ups, Malpedia. I found a link to the code earlier, which is what I'm trying to find now. Just bear with. Let's try that. This was one of the articles I was reading. And I think one of these had a link to some code. The gist of it was like a build script almost written in Rust. Rust backdoor capable of downloading and executing further malware on infected devices. Rust bucket stage 1, Apple script dropper. That's a blast from the past. I didn't even know Apple scripts still existed. Okay, shell script commands. I think some of the Rust code actually does like it uses external process or was it stood process or something. Right, let's I'm trying to find the link that I had earlier. Just bear with me. XE, so that's going to be some sort of Windows thing again. XE is composed of a main module along with 4 other files, CLI detectors, fetch and patcher, which give a good idea of the functionalities of the tool. Before using a tool, the payload has to be prepared, which can be done using the Python script parser.py.
The script optionally XORs the payload with a key determined by the user input, then appends a PNG header to the encrypted binary for further obfuscation. Okay. After that, the payload can be uploaded to one or more servers. A JSON file containing the URLs has been created and subsequently fed to XEHU2 via the command line. Let's oh, it only mentions Rust there, so okay. Yeah, here we go. Let's look at the code. Let's jump to. Let's look at cargo to start with. So it's kind of my habit is to look at cargo first. So it's using URL request Tokyo clap Zerde MD5. Okay. MD5 is kind of a pretty old. Rust crypto memexec walked. I don't know what that does, but I can take a good guess. Rust memexec. Right, let's and features. So it's Win32. Let's see what it does then. So we know it runs a Python script to set up a kind of a fake PNG file with some naughty stuff in it. So these are the 4 files that are references that are obviously part of the project. So with them, that uses loader options, std error, std process exit. That was kind of what I was thinking of. An MD5 context, memexec p parser, memexec p loader. So all this is new to me, but I think sometimes it's almost best to explore and share things when it's all new to you and it's fresh. If I looked at this for a couple of weeks, I'd probably just think, meh. So let's really see what this does. This is asynchronous. It's returning result of unit type if it's okay. Else, a smart pointer, so a box of a dynamically sized error. So it's taking v hash and so it's doing some sort of, it's taking an array and then context hash computes returns. How they've used return there. They didn't need to do that. This is one of the interesting things actually. When you look at that I'd noticed earlier, when I was looking at the code, I mean, some of the stuff is just light years ahead of what I can understand because I'm not I'm not a hacker. But I was noticing already just from my 1 and a bit years of Rust coding, I was noticing mistakes that they'd made, or they're experts in hacking and they're not experts in Rust. But so I was quite pleased that I was. So yeah, you don't need return. You don't need to return there when you wouldn't need that semicolon. I was also noticing they were using if else a lot, whereas they could have used match. And just to kind of get a second opinion, I just pasted their code into ChatGPT, and then I just said, should this be match? Should they have not used return? And kind of all of the things I saw were actually I got ChatGPT agreed with me. So CFG debug assertions. So it's doing error checking for the correct arguments. Using match there. Patcher, patch.etw. So that is that's the function there, patch etw. Get event consumer from What is this site? Is this a naughty site or is this a legitimate site that kind of... Okay, after the introduction of PowerShell detection capabilities, attackers did what you expect and migrated over to less scrutinized technologies such as .NET. Fast forward a few years, and many of us... Okay, don't know when this was written. Yeah, .NET. Okay. So .NET is an attack vector. Not really much of a surprise. You can see the DLLs, the DLL. I wonder if they use any unsafe Rust. That would be unsafe. Yeah. So I don't know a great deal about unsafe, but I know that it kind of gives you extra ability to do stuff which potentially you can misuse memory. Yeah, lots of exe. When I see exe anywhere, I just think if somebody asked me what my first thought of exe is, I'd just think malicious virus. So this is so key dot... What's going on here? args.key.clone.unwrap as bytes to vec. Okay, so this I wouldn't have expected to see if is some there, but you can use is some and is okay when you want to return an option to a result and vice versa. Wow, what's going on here? Is that's an XOR, isn't it? So it's modifying the payload because it's yeah, it's dereferencing. It's using the asterisk dereference. DLL process attach. That looks very Microsofty. memexec DLL. I've no idea what all that's doing. Let's hopefully you'll forgive me for asking ChatGPT to explain. Explain this Rust code I found. I wonder if ChatGPT is going to actually know that it's potentially malicious. The line calls DLL function from the memexec module. Let's just get rid of the sidebar as well. What's it actually doing? Here we go. The code attempts to execute a DLL from memory using the memexec DLL function. That sounds just dodgy. That sounds really naughty to start with, doesn't it? If the function succeeds, nothing happens. An empty mucharm. Okay, so if the function fails, it checks if the program is in debug mode. Let's go back to it. Run exe in memory. So server list. Fetch server list. Can we go there? Let's jump there. So there's a function server list. So try to fetch PE from, I don't know what PE is. This is where it uses request. So it's going off to that URL and trying to download the PE. Payload executable. And it's getting that all in memory as bytes, maybe. Okay, iterate through the list to fetch binary. So it's going through a list of servers to find a binary. Okay, it's all quite naughty stuff, isn't it? um, I don't think it's funny to do malicious things, but I think it's amusing to try and understand the mindset of the hacker and their their creativity to solving certain or to working around problems. Freeze, this is the one I was looking at earlier, and I partially understood, so it's been archived. Presumably it's here for educational purposes, and it's no longer going to be worked on. Okay, Freeze.rs, let's just go straight there. There's a payload toolkit for bypass. I don't know what EDRs are, but using suspended processes, direct syscalls written in Rust. So DLLs again, dreaded DLLs. As far as I know, DLLs the same as or perform the same job as kind of a shared object in Linux or Unix. That's my crude guess and my crude understanding. So again, they use clap digest SHA-2 rather not MD5. FS file buffer process command. So I think these are probably these seem to be the common. So yeah, reading files, environment variables, some hashing, clap. This was interesting. I believe this is like a build script that then builds something else. So entry to the main, let matches equal. Shall I make the font just a bit bigger? Is that helpful? Maybe that's too big now. I'll go back. So it's passing the arguments which are output, so the name of the output file, name of the input file, generates verbose console information when the payload is executed. This will enable the hidden window feature. Disables ETW. So these are all options for kind of seeing what's going on, I guess. Sandbox. Enable sandbox evasion by checking is endpoint joined to a domain. Does the endpoint have more than 2 CPUs? Does the endpoint have more than 4 gigs of RAM? So if is present, is that a Rust function? I think it is, isn't it? I would expect it to be. Is ah, I don't know if it's a built-in. Not used it before. It's commonly associated with clap. Okay, you can see this is out of date because it's referencing clap 3, which is quite out of date now because it's, I think, clap 4.5.4 as of June 2024. unwrap or contains. I'm mainly looking at the functions that are being used here. So we've got contains, value of. I don't know where value of comes from. Let's ask ChatGPT about value of as well. Value of a Rust built in. Clap again. I probably should use clap more than I'd know things like this, but most of the time I'm not really trying to learn Rust with a view to writing small command line things. Payload exe. So you're doing split, next, unwrap, lots of unwrap. I don't know if any experienced programmers are watching this. Probably not, but even if anybody with some medium experience can comment on this. If you see unwrap too much in some code, is that a giveaway? It's a code smell, isn't it? Set up cargo. I found this interesting. So this main.rs would be compiled, and when you run it, it would run cargo to build something else. That's how I understand it. So you notice this is mainly kind of functions without many join. Could they have used that doesn't look quite right to me. Could they have used the right macro there, or format? What do you think? I would say that you could use right there just to kind of concatenate all that. And then we just got all the usual file stuff. So open a file, create a buffer of size 1024. Loop through the file, try and read it, update the hasher, then finalize the hasher to get your result, and then you end up with a hash. I don't quite know what the hash is for, but that's not really a concern. Just reading this out of curiosity, really, just to look at other people's code, and I'm thinking this is probably not great code to base your career or your how should we say it, your classic your it's probably not great code to base your whole kind of studies on, but just out of curiosity, it's interesting to see how Rust can be used and misused, I would say. Wow, all these use. Win API, win proc. Whenever I see NT, I still think of Windows NT. I don't know if that's what's going on there. Okay, so at least they've split up. They have used we got lots of functions. I'm trying to find any structs. Wow, this looks quite dirty. It's doing some really. Is this assembly as well? I don't know. But it's registry stuff, isn't it? I think Windows registry. Wow. So Freeze.rs. I would think even if you're doing like a university or a computer science degree, I would think you probably would these days look at malware and now probably look at Rust as well. So Freeze seems to be one that was always quite popular, but I presume it's been dealt with, so to speak. So 2022, 2023. Bitdefender Hive ransomware's offspring, Hunters International takes the stage. Luca Stealer targets password managers and cryptocurrency. Let's read that. Threat actors have begun migrating from older and well-known compiled languages such as C and C++ to more modern languages. Let me just try and make that a bit wider. Threat actors. These newer compiled languages such as Golang, Rust, and Nim. These languages give developers the ability to compile programs for both Linux and Windows with little. Okay, so it's making it easier to make cross-platform malware. Rust's adoption for malware is in its infancy compared to Golang or Nim. However, that's quickly changing. Recently, there have been a few notable examples of malware written in Golang and Rust being used in the wild. Such examples include the Black Cat ransomware and publicly shared information stealer dubbed Luca Stealer. All this is new to me. I've been so busy kind of learning Rust from books, which I stand by, but just means you don't spend hours and days looking at other stuff. Luca Stealer was released publicly under an open source code model. The public release of the source code for Luca Stealer allows security researchers who are unfamiliar with the Rust programming language to gain insights on how the Rust language is leveraged to design the malware. All right, this really is starting from scratch. Hello world. Okay, the defaults for the It should also be worth noting that Rust strings are not null terminated. This can cause issues with reverse engineering tools during analysis, expecting strings to end with a null byte. Since there is no null byte to denote the end of a string, strings can overlap depending on where the compiler lays them out in the binary. So it's making detection and an analysis slightly harder because it doesn't conform to some of the historic patterns. Okay. This could potentially leak username of the user who compiled the program, depending on where the disk was put. Oh, okay. We're getting into C land here as well, so I won't dwell on that too much. But the program will then set the call to stud rt lang start internal with the address of the main function of the written Rust program, and the program argument array, environment variables array, and program argument counter. Here the address of the main function of the user-defined code is being placed in the RAX register. Some tools will fail to analyze this section of the code properly. I guess analysts have been just so used to just having only really needing to analyze C, C++. So they're obviously just analyzing the assembly and create function, variations of this technique, revisiting embedded strings. The Rust compiler embeds many diverse types of strings in the binary. Some of the more notable ones are due to Rust dependency management system. The Rust build system cargo has a dependency similar to npm. If a project wants to import base64, then it can be done. So cargo toml. So you have a binary which is statically compiled with the specified external crates. During compilation, the compiler will include all the panic information for each crate. This includes the path to the crate on disk of the system. Okay, so because it's statically compiled, you can see or when you analyze it, you can see the dependencies. I created a GIDRA script to find crates imported by a program based on these strings and list them. So Rusty Mangle. Unknown Rust Malware sample analysis. I'm finding the main function. Malshare link. This is an unknown malware sample written in Rust. Looking at the debug data reveals the following path to the built PDB. Here we go. So running this is a Python script. So it reveals the binaries that are inside. Sorry. It reveals the other crates that were used. Look, so we've got base64, hyper, Tokyo, request. Most of the dependencies listed are sub-dependencies and were not explicitly specified by the malware developer. Identifying which ones are a sub-dependency of a Rust crate can be done by looking at the crate's documentation. There is a cargo command, isn't it, where you can list all the dependencies. I know John Genset talks about it. What is the cargo command to list all dependencies? Oh yeah, just cargo tree, isn't it? And I guess you can you drop down to other levels so that you know the dependencies of the dependencies? Yeah, depth 1, all targets. Okay, yeah, cargo tree was what I was thinking of. Let's just run that. So just go into here and just see what junk I've got lying in here. So if I go to I'll go to TL, which is just a test project, cargo tree. I haven't added anything. So if we just do cargo add, let's just do request. And then do cargo tree. There we go. So it knows that it knows that we've added request, and then it knows that request relies on these. So request uses base64, it uses bytes, it uses encoding, and then it knows that encoding uses. So that's a really useful command, especially if you're worried about vulnerabilities in dependencies.
It's not something I've really ever needed to concern myself with, but John, if you watch a John Genset video, he talks about it in a lot of detail, obviously because he's so good. But yeah, so cargo tree. So obviously this is a lot of it's showing a lot of assembly here. Obviously string literals, they will be, I think you can read those because they're not obviously not on the stack or on the heap, they're actually compiled into the code. Mhm. The ABI, the application binary interface, the Rust compiler constantly changing. This pattern has the potential to change in future releases. Rust features which make analysis difficult. So let's unpick this. The way Rust handles errors and its native implementation of memory-safe operations makes reverse engineering significantly more difficult. Wow, that's interesting. Essentially, the compiler will insert a lot of code that does the error checking for the developer. Yeah, so if you're new to Rust, then it's like the compiler is a nightmare. But obviously, that means once you've pleased the compiler, it means your code is good. So you're just basically front loading any potential bugs with your software. Examples of this are bounds checking, array accesses, and statements which could potentially read or write outside the appropriate allocations of memory and cause the program to panic. Rust is designed to reduce undefined behavior by inserting these checks into the program for the developer, both at compile time and runtime. A language such as C or C++ will not implement these checks for the developer, leaving them with the responsibility of memory management and safety, which anybody who knows much about Rust will be acutely aware of this being a massive reason to use Rust. Rust does not have a stable application binary interface for calling conventions, and the compiler is constantly changing with each release. The generated binary file from a Rust project can vary drastically depending on what compiler version is being used. Okay. This makes it increasingly difficult for reverse engineers and detection systems to identify the behavior of Rust malware, even if they have analyzed a previous version of the same malware family, due to a high degree of variation in code patterns. Okay. Some of the lesser known features of Rust are its malleability and low-level interfaces. Rust supports directly managing memory through pointers, inline assembly, and even compiling code without the standard library. Compiling code without the standard library is not. Yeah, I was just about to say that's intended for embedded devices where you don't even have the standard library. A Rust developer can create a program without depending on the Rust standard library. Yeah, so if you were doing something for, I don't know, Arduino, for instance, and only import system libraries as needed. The resulting program will be significantly smaller in size, but still include all the dynamic error checking. These low-level features make the language great for systems development. However, this also gives malware developers a lot of flexibility on different memory obfuscation techniques they can employ to make analysis increasingly difficult. Wow. Conclusion, there has been a recent rise in malware utilizing newer programming languages, and Rust is seeing an increase in popularity among malware developers.
Although adopting a new language creates more work initially for malware developers, some new languages give them the advantage of lower antivirus detection rates and making reverse engineering more difficult for analysts. Rust is still an uncommon language for malware. Okay. However, it is starting to become increasingly prevalent in ransomware and information stealing hardware. The detection landscape for this malware lacks maturity when compared to detections for malware developed. Well, yeah, obviously, yeah, that makes sense. Yeah, so basically, as the language matures, it should have better detection. So Rust is still an evolving language, and much of the language could potentially change in the future. There are some commonalities and artifacts which can be used as indicators for the behavior of unknown Rust programs and techniques. What I would say is, surely it's incumbent, or it's important for creators of operating systems to, um, yeah, ensure that these attack vectors are minimized. So further research into Rust reverse engineering can be done through more dynamic means such as debugging. Yeah, so there we go. I think that's confirmed our suspicions that Rust is, how should we say, because it's newer, it's got a few possibilities, like not using the standard library. It makes it harder to detect patterns for security analysts. P2P infect, the rusty peer-to-peer self-replicating worm. I'd be interested to know if these vulnerabilities on Linux run on sort of SE, like Red Hat SE security enhanced versions or not. Let's read this. Redis. Debian, Lua. Oh, so I've been logged with NIST now, I would imagine. So Debian specific. I, uh, it's not even my cognitive bias because I actually run Linux Mint, and I found Red Hat to be, I don't know, not very user friendly, but yeah, there we go. So possibly Linux, like Red Hat or equivalent, might be better placed to avoid certain exploits, such as this particular one, P2P infect. I guess kind of the summary of this is that nobody's safe, and the more third-party software you run. Oh, so they run some honeypots that we use to identify and study novel, new cloud-based attacks across public cloud environments. Palo Alto Networks customers receive protections against types of threats discussed in this article. Again, it's all about defense in depth. So obviously Palo Alto is a software, a firewall vendor. So you want security to kind of kick in at the firewall level, cloud provider level, the operating system level. So what would you do? You'd recommend using a next generation firewall with deep packet inspection, intrusion detection systems, all that stuff, and you'd want your cloud provider to be using sort of multiple vendor firewalls, and then you'd implement a software firewall within your cloud network. And then you would be running a secure version of Linux actually on your, you know, as your web server within the cloud, if that's what you're doing, if it's within the cloud environment. Yeah, it says cloud environment. So there we go. I'll wrap it up here, but hopefully this has just been a bit of an eye-opener, really, to the fact that Rust can be used for. It's been an eye-opener to me, and it's certainly not. It's not kind of a criticism of Rust at all. It's almost a compliment, but it just does show that there is code out there that you can look at, you can learn from. Just be mindful that sort of certain libraries often are commonly used, even in malware, such as clap, request, std process, Tokyo. So yeah, and just remember that if you didn't know that already, yeah, cargo tree is a good command. So that's just with one. If I had if we do a cargo add, oh, what should we add? Let's just do Surday. And now if we do cargo, we do cargo tree. No, should we do what was it? WC-L 161. So yeah, that's a lot of dependencies and a lot of crates and bits and pieces that potentially could be attack vectors. So yeah, thanks for watching. This has been a bit of a random video. I don't know if I'll do these regularly, possibly not. But yeah, let me know if this has been interesting. If you've got any comments on it, if you if you think the code that we looked at was good code, bad code, clever code, whatever. So yeah, just share your comments. I'd be interested. So on that note, I'll wrap it up here, and thank you for watching.